So far this week, we've had quite a few questions about this particular problem in the homework. The law of cooling. And it is a bit tricky of a problem. It's one that I'm happy you're getting exposed to, but I will also promise it is not on the exam, so you don't have to worry about that. However, I'm going to go ahead and make a video walking us through this particular problem, since the Help Me Solve It does not do a very good job of that. I am disappointed in what I saw in Pearson's Help Me Solve It. So, for this type of a problem, we are going to use the equation T of t is equal to S plus T sub 0 minus S e to the kt, where S is the surrounding temperature, T sub 0 is the initial temperature, E is our constant E, K is the cooling constant, which can differ depending on what sort of object we're looking at, and T is the amount of time that has elapsed, and then T of t is the temperature of the object after that amount of time. So our object in this case is a body. And when we find the body at 3:30 a.m., it's 93 degrees. So that's going to be our T sub 0 to start. The temperature remains a constant 72 degrees. That's the surrounding temperature. And at 5 a.m., it's dropped to 83 degrees. So let's make some notes over here. T sub 0 is going to start off as 93 degrees. S is going to start off as 72 degrees. T itself, oops, not that first. Our time is going to be 90 minutes. Let's go with time in minutes. That will make things easier. And then T of 90, we are told, is 83 degrees. And we can use all of this to solve for K. So we have 83 degrees is equal to 72 plus, in parentheses, 93 minus 72, e to the k times 90. So we'll do a few things in the way of simplifying. We'll subtract 72 from each side, which gives us 11 over here. 93 minus 72 is 21. And let's write that as 90k. That looks a bit nicer. Divide both sides by 21. So we have 11 over 21 is equal to e to the 90k. Convert this into a logarithmic form. So the natural log of 11 over 21 is equal to 90k, which means k is equal to, sorry, that's a lowercase k, is equal to the natural log of 11/21 over 90, or as my math lab has been writing this, 1/90 times the natural log of 11/21. So that tells us for this particular scenario, we have the temperature after time t is equal to the surrounding temperature plus our initial temperature minus the surrounding temperature, e to the 1/90 natural log of 11/21 times t. And the problem tells us to assume that we've got a healthy victim at time of death, so 98.6 degrees Fahrenheit was the body temperature at that time, and we want to figure out at what time the murder took place. Well, we know by 3:30 The temperature was 93 degrees. So we're going to make 93 degrees be our later temperature now. 72 degrees is still the surrounding, but the initial is now 98.6 degrees. And we have this whole big ugly K up here that we can work with. And let's pause for a second. Why am I leaving K like this instead of just making it a nice little decimal approximation? The reason is exponents are finicky. A slight rounding error in either the exponent or the base can really mess up our end result. So I'm going to avoid rounding as much as possible. Since I can write this out, as much of a pain as it is, since I still can write this out exactly, I'm going to leave it exact until the very end. But now the process really follows what we did over here on the left. I'm going to subtract 72 from each side. But I've already done that subtraction that was in here, so that's 21. 98.6 minus 72 is 26.6. Divide both sides by 26.6. We get 21 over 26.6 is equal to e to that big, long, ugly K times t. And now a side note, MyMathLab, if you use the Help Me Solve It, will tell you we need to simplify this fraction, which means we can't have a decimal in the denominator. We have to move that over by multiplying by 10. So this becomes 210 up top. And then we have to reduce that fraction, and that is worthless. We are using a calculator to figure out our decimal. There is no need to simplify the fraction. That is my point of gripe with the Help Me Solve This in MyMathLab here. They waste a lot of your time doing useless work with fractions. Leave it like this. It's good enough. Take the natural log of each side. Or if you'd prefer, convert this into a logarithm. Scroll down a little. Multiply both sides by 90, divide by the natural log of 11/21, and we get t is equal to 90 natural log of 21/26.6 over the natural log of 11/21. And yeah, trying to say 21/26.6 is horrible. That's why they ask you to reduce that fraction. I should have said it 21 over 26.6. And then when we plug this all into our calculator, if we are careful, we get about 32.9 minutes. Now let's check the question. It asks us to determine when the person was murdered. This 32.9 minutes says that it took about 32.9 minutes from the time of the murder until we made that first measurement. Well, time, we aren't going to deal with that whole 0.9, so we're actually going to say 33 minutes ago. So the person was murdered "33 minutes before 3:30 a.m. Oh, that's pretty cool. We can just figure that out. 33 minutes earlier. Well, 30 minutes earlier was 3, so 33 minutes was 2:57 a.m. And that's how to deal with the law of cooling.